All right, so today we're looking at optimization. Our goal here is going to be to minimize or maximize something. And y'all as calculus students, when you see min or max, you're automatically reminded that to find a max or a min, I need to set the derivative equal to 0. So you're going to be taking derivatives today. You're going to find your equation, take the derivative, and set it equal to 0. Let's talk a little bit about what we're talking about here. If you look at this first problem, a manufacturer wants to design an open box that has a square base and a surface area of 108 square inches. What dimensions will produce a box with a maximum volume? So this company knows they're going to use 108 square inches of cardboard or whatever it is, and they want the maximum volume. They don't want to use more square inches because materials cost money. You want the smallest package with the greatest volume. So, and I don't know how when I typed this, it did this, but let's look here. I want you to look at our kind of little set of rules. Again, I don't know why it went off the page. It was supposed to be on the bottom and I got spaces in when I printed it. So the first thing we have to do is identify, what do we want to find? Do we want area? Do we want volume? Do we want price? What are we looking for? Figure that out first. Second, if you can, sketch a diagram. The ones we're working on over the next couple of lessons are almost all diagrams, figuring out how big should the area be? How big should the volume be? We write a primary equation for the quantity to be minimized or maximized. Where are you going to get this? This is going to come from your head. These are things you already know, like the area of a rectangle, the volume of a box. These are formulas you're bringing with you from geometry. Now let's think about something. When you bring me a formula from geometry, let's say it's the volume of a box. It's length, the volume is length times width times height. Now let's think about that. In calculus, do you want more than one letter? If you can help it. No, because if you have more than one letter, then you're going to have to use implicit differentiation, possibly the product rule. It gets messy. So what you, the calculus student, would like to do is say, can I whittle this down to one letter? Right? So if you can get it down to one letter, that's all the better. So reduce the primary equation to having a single independent variable. You may have to find and use a secondary equation that relates the independent variables, meaning maybe you're looking for volume and they gave you surface area or something and they're allowing you to get a letter by itself. Again, this right here is from your head. And what I mean by that is it's prior knowledge. It's probably some geometry, right? Or something they're giving you. So you're going to get your equation of the thing they're asking you for. You may have to go off to the side and say, okay, I don't know that, but I know area and I can work a variable out. Then we'll determine a feasible domain. How big can X be? How small? We know that if we're looking for dimensions, we can't have a negative answer, right? You can't have a box that's a -5 inches long. So we don't even worry about those. We kick out negatives. What makes sense? And then we solve using calculus. How do we solve using calculus? What's our process? Y'all already told me. Set what? Derivative what? There you go. Set derivative equal to 0. So the basic idea of today is you're going to go get you some geometry formulas and you're going to take their derivative, set it equal to 0 and figure it out. Not too bad, right? Are you ready for this? All right, let's go. A manufacturer wants to design an open box that has a square base and a surface area of 108 square inches. What dimensions will produce a box with the maximum volume? Okay, so I'm a company. I want to use the least amount of cardboard, but I want the biggest amount of volume so I can fill it with whatever I sell. Dog bones, cereal, right? Lots of things come in boxes. So first, let's draw a box. Now the key here is square base, right? So let's draw a box. Basically like well, I guess I can make that solid, right? So there's my box. If the bottom is square, my base is square, then I can call this X and this X, true? If it's square, they're the same. And what am I going to call this piece going up and down? H for height? I don't have anything that tells me if it's twice the base or anything, so I have to use another letter. Now, let's see what they told us. Let me get colors so we can match it up. Okay. So step one said for us to find the main equation that we needed. We want maximum volume, right? We're given surface area, so let's work with surface area for a minute. How big is the surface area? 108 inches squared. Well, if I'm looking at a box like this, what is the surface area? I've got a front and a back that are the same, right? You'd all agree the front and the back of the box are the same. And we have a left and a right side that are the same. So if I find that, I know both of them. And we have a top and bottom are the same, but do I need both the top and the bottom? What does an open box mean? No top, right? So I'm only going to have a bottom, no top. Does that make sense? Okay, what's the formula for the front and the back? It's what? X times H. The front and the back is this piece right here, and that area is XH. So 2 times XH. Plus, I have a left and right side. What's the area of the left and right? That would be this piece. What's the area of that? Is that also XH? It is, and I've got 2 of those. Now, what's the area of the bottom? That's that right there. What's the area of the bottom of that thing? X squared. And if I add up all those sides, what does it equal? True?
Miss Coughlin,
Yes, ma'am.
when you did for the left and right, for the H, is that the left side or the right side?
It's the height of the box. All of these are H, right? It's a box.
Oh,
So they all have the same, a box would have the same height.
okay.
Okay, so 108 equals 2XH plus 2XH plus H squared. This is just your surface area formula from geometry. So 108 equals 4XH plus X squared. I'm just going to leave it there at this point, right? I did the best I could. That's all I can do right now. We have our box drawn. Here's part 2. If you look at our list, we drew a diagram. Then part 3 says to what? What do we write on part 3? We said to find the one we need, right? If you look back at our list, part 3 says write a primary equation that is to be maximized or minimized. We want to maximize volume. So volume equals what? What's the formula for volume? That's true, but what is the length of this box in our diagram? Yes, the length is X. What's the width? What's the height? Just h. So now we realize we've got a little problem. We don't want two different letters. We want our variables. We want one variable. But they gave us this equation. So which of these variables would you like to eliminate? The h. So can you go over here and get h by itself so you'll be able to plug in something here that's not an h? Can you do that over here? Of course you can. That's 108 minus x squared equals 4xh. Now how are you going to get the h by itself? Divide by 4x. So h equals 108 minus x squared over 4x. This is the purpose of that other information they gave you, so you can eliminate variables. So now instead of typing an h there, I'm going to say, well, x times x is x squared, but instead of having h, I'm going to have this, right? Whoops. Everybody okay with that? You know, you want to write things to yourself here so you can follow this yourself. Okay, now what happens with this x and one of the x's in my x squared? Will this x here cancel with one of those and bring that down to x? Okay, so I can cancel that, and then I have v equals, now I'll distribute 108 x squared minus x cubed all over 4. We haven't done any calculus yet, right? We're only doing geometry right now. We haven't got to the calculus part. Now, what does your experience tell you about fractions like this? Can you split that up to make it easier? Yes. You're allowed to do that, right? And this makes your problem easier because we can, what's 108 divided by 4? Is that 27? 4 goes into 10 2 times, which is 8, yeah. And I'm going to write that 4 like this because I know where I'm headed. Where am I headed? Where are y'all going with this? What did we say how you would do all these problems? If we're maximizing or minimizing, we're going to find a derivative and set it equal to 0, right? And this problem wants you to maximize volume. That tells you you have to find volume, then take the derivative, then set it equal to 0, right? We are now going to enter, let's look at our notes. We are now going to enter step 6, which says to what? Solve using calculus. We haven't done any calculus yet. Now we're going to solve with calculus, which means set the derivative equal to 0. So what is the derivative of this?
Miss Coughlin,
Yeah.
we can't see. Can you move the paper down a little?
Yes, and look what I did. I wrote squared. That's not a squared, is it? I can't read my own writing. That's really just a 1. There we go. That's just x. Okay. So now, what's the derivative of 27x? 27. What's the derivative of 1/4 x squared? What's 3 times 1/4? Right? Y'all okay with your fraction? So now that I have the derivative, what are we going to do with that derivative? What do we do with our derivative? What do we do with our derivative? Set it equal to 0. Then of course, this is negative. I would bring it to the other side to solve for x. How do we get rid of a fraction? Multiply by the reciprocal. Now, normally, if we have x squared equals 36, it would be plus or minus 6. It's only plus 6 because we are looking for length of the side of a box. We can't have a negative, right? So x equals 6. Now, can you take x equals 6? Can you plug it in here to find the height now? So plug that in. So x equals 6 inches. And h equals, if you plug 6 in here, 100 minus 36, or sorry, 108 minus 36 divided by 24, which I think that gives you 3. So we want a box right? We want a box that's 6 by 6, 3 inches tall. That's going to give us the maximum volume in the box. Is that okay?
Ms. Kaufman?
Pause for a second. Okay, so hopefully you kind of found that cool, that you got to find a real world example of something that's going on. If you're eating a snack right now, it's in a package. Somebody figured out the best way to package that for least cost. Plus, of course, sometimes we want things to look pretty, so we got to take the graphic design into account. True story. I used to work for Lockheed, and I also worked for a subsidiary, a company that did work for Lockheed, and I worked with a guy who at one time had worked for Dr. Pepper. And if y'all look at the bottom of a can of a, like you can look at yours, are there numbers on the bottom of that can? Look on the very bottom. Is there ink numbers? There's ink numbers on the bottom of a can. They're on every can. Do you think that ink costs money? It does. Just by reducing the amount he was paying by a few pennies, he saved the company over $100,000 a year. So all of this packaging and this calculus goes into purchasing. It's all part of a business that's running. It's really kind of cool if you think about it. All right. We're going to do one more that's a little bit different. Then I'm going to give you time to work. I don't want to go on. We're not going to do number 2 here, because that kind of goes off back into revenue, and we're kind of on a little bit different path right now. Again, I'm sorry that this printed weird. I don't know what I did. I must have hit enter and pulled that down. The product of 2 positive numbers is 288. And the product of 2 positive numbers is 288. So I'm going to pick positive number 1, x, and positive number 2, y. And what does it say the product is? 288. Now I'm already thinking ahead that I'm going to want to get rid of one of those letters. Let's look. Now they're telling me minimize. When you see the word minimize, what does your brain go forward into doing? What do you know you're going to do? Yes, you're going to end up finding a derivative and setting it equal to 0. So this says minimize the sum of the second number and twice the first. Okay, so the sum of what? The second number and twice the first. So twice the first and the second. That's my formula, right? Now this is the thing that I'm going to take the derivative and set it equal to 0 because they want me to minimize this. But I'm unhappy with that equation. I don't like it. Why is this ugly? There's one reason it's ugly. Why is it ugly? Well, this is just some, but yeah, we have 2 variables. I can't do that. Ooh, but they gave me some information over here. Could I solve this for one of my variables? Sure. Should we get y by itself? Let's get rid of the y. Y equals 288 over x. Is that true? That's true, right? So now can I go over here and say the sum is 2x plus y, but instead of y, what can I write down? Now this looks pretty. I only have one variable and I'm a wizard at that. Except for I have to take the derivative and there's a variable in the bottom. Could you write this so it would be easier? What could I rewrite this as? Can I do that? And then I can just use my power rule. So now I'm going to find the derivative. Derivative of 2x? 2. Now, what's the derivative of 288x to the negative 1? We're going to multiply, so that's minus 288. So we're good. Now, I'm ready to, that's the derivative. I'm ready to do what with the derivative? Yes. So I'm going to say 0 equals 2 minus. Now I'm going to rewrite this. I don't like negative exponents. It's hard to plug numbers in. So I'm going to think about it this way, right? And you know derivatives, they grow on the bottom. If you were thinking back to when we studied derivatives. Now I'll just get it equal to 0. And I'm going to move that over because I want positives. So 288 over x squared equals 2. How am I going to solve this? I'm going to multiply both sides by x squared, right? Yeah. So 288 equals 2x squared. I would do this in one step in my head, but in my notes, I might want to remember what we did. Now, when I say x squared equals 144, is x going to be plus or minus 12 or just plus 12? Read your problem. Plus 12. They said two positive numbers. Now, normally this would give me a plus or minus 12, but I'm going to ignore that negative 12 because they told me to. So now that I know x equals 12, I'm going to go back to this problem and say y equals 288 over x. And I can solve for y. Y equals what? 24. That's twice as big as that. So now I have an x and I have a y.